We have a ball starting from rest, so initial speed is 0, moves horizontally. 6 positions of the ball are shown at time intervals of 1 milliseconds. The horizontal distance between the initial and final positions is given as 0.05. We need to find the average acceleration. So to solve this question, let us use the first CORT equation. S is equal to ut plus half into acceleration into time square. Distance is given as 0.05 meters. So let us write S as 0.05 equals to initial velocity is 0 since the body starts from rest. So we'll write a 0 plus half into acceleration multiplied by time square. Now it is the acceleration which we are supposed to find. So we need to deduce what is the value of time. Now 6 positions of the ball are shown as you can see in this diagram at a time interval of 1 millisecond. So how much will be the total time? So let me draw the time difference between these two positions is 1 milliseconds. Between the next two is also 1. Likewise, if I keep adding the ones, so the total time between the first, which is the initial, to the final position will be 1, 2, 3, 4, 5. So there are 5 gaps between the positions. So we can say total time is 5 milliseconds. So total time for the ball to go from the starting to the final position is 5 milliseconds. And let us write T as 5. And we will need to convert that into seconds. So 10 to the power minus 3. And now let's simplify. So we'll get 0.05 and let us try to make acceleration as the subject. So the 5 into 10 to the power minus 3 squared, we will write in the denominator. And let's try to simplify this. So the numerator is 0.05 multiplied by 2. And in the denominator, we can write 25 into 10 to the power of minus 6. And if we simplify this expression, we will get the value of acceleration as 4,000 meter per second square. And if we go back to the options, it is option B, which is the right answer. So here we have a ball which is thrown upwards and the graph is between the height traveled by the ball and the time. So the x-axis is time and the y-axis is the height covered by the ball. And we need to find the height at a particular time t. So now there are two ways of solving this question. The first method which we are going to do is a smart method. So in an exam situation, we will try to get to the answer without going into calculations, without using any formula. So how does that method work? So that is the smart method. We are going to analyze the options and then we will check one by one which options can be eliminated, discarded. So we are using the method of elimination. So how do we do that? Now, if you analyze this graph carefully, let me just write it here. From the graph, it can be deduced. If you observe at time t is equal to 0, which is the starting stage, the height of the ball is 0, and also at capital T, the height is 0. Now, what is this capital T? So for that, let us draw a quick diagram. It is saying a ball is thrown upwards at time t is equal to 0. Let us label this. First of all, consider this as the ball. It is thrown from a point A and it goes up. It is going to go up till it is reaching the maximum height. Let's call the maximum height as B, and then it comes back down along the same line. So let's consider this as point C. Now point A and point C, they are actually the same points, but just for the sake of explanation, I have separated A and C. So in this graph, where are A, B, C? A is the starting point. So time t is equal to 0 will be point A. B is the maximum height. So over here, if we write, this is the point B, and the point C is over here, which means capital T signifies the total time taken by the ball to go up and then back down. So in our smart method, what we are doing, first of all, we observe from the graph that the value of height is 0 at two particular points. First, time t is equal to 0 and time t is equal to capital T. And the question wants us to figure out the expression for the height at a particular time t. In the diagram, let me specify that. So let's say the ball starts from A and at a particular time, the ball, let's say, is at this particular position. So the height will be this. So the question is, we need to figure out the expression for h in terms of time t. How do we approach this question? Using the options method, we are going to put the observations which we just deduced into the options. Let's look at option A, which is half gt square. Let me write this separately. Option A states that the height of the ball at a particular time t will be half gt square. Now, if this option is indeed correct, then it is going to satisfy our observation. So if you put t is equal to 0 here, of course, the value of height will come out as 0, which means option A is satisfying the t is equal to 0, h is equal to 0 condition. But if this answer is correct, then it has to satisfy the second condition as well. So if instead of t, we put capital T, then the height will come out as half g capital T square. Now, capital T is not 0, which means the height value will definitely not be 0. Hence, option A is not satisfying the second condition. And for the option to be correct, it needs to satisfy both the conditions. Hence, option A we can eliminate. Now, let us look at option B. It is half g capital square. Now, this expression doesn't even have the variable time, small t, because capital T here is a specific time. That time is the time taken by the ball to come back to the ground. And that capital T is definitely not 0. To sum up, we have to find the height at a particular time t. Now, t is the variable, which means the expression should have the small t, the time variable. And according to option B, the height at any given time t is a constant, which of course is not possible. So now we can deduce that the value in option B, which is half g capital T square, is a constant. And of course, it does not satisfy the second condition, which states that at time capital T, the height should be 0. And that is why even option B we can eliminate. Now let us look at option C, and let's try to put the condition time t is equal to 0. So if we put time t is equal to 0 in option C, let's see what do we get. Half g capital T into capital T minus 0, since time we are considering as 0. So if we simplify this expression, we will get half g capital square, which is the same expression which was there in option B. Now, half g capital T square is a constant value. Let us write this down. Capital T is a constant. Now, which is not possible because the height at a particular time t cannot be a constant. It has to change depending on small t, which means even option C is incorrect, which means we are left with option D, which is the right answer. But still, let us analyze why option D is correct. So let us try to put t is equal to 0 in this expression. Option D, it will become half g into 0 into capital T minus 0, which when simplified, it is just 0, which means it is satisfying the first condition, which is the height needs to be 0 at the starting point. Time t is equal to 0. Now, instead of the time, we will put capital T. So let's put that in and let's see what do we get. Half g t, the small t, which in this case will be capital T, multiplied by capital T minus capital T, since we are considering time is equal to capital T, which will also become 0, which means the height value is 0 at both the points, time t is equal to 0 and capital T. Hence, option D is satisfying both the conditions, and that is why we say option D is the right answer to this question. So here we have a stationary mass of 1 kilogram kept on an inclined plane. The inclined plane does not have any friction as it is mentioned. The object travels up the incline for a distance of 3 meters, and throughout the motion, the box is being pulled up by a force of 6 newtons, and the direction of the 6 newton is parallel to the surface of the incline. And when the box reaches the topmost point over here, it is 1 meters above the ground. And we need to figure out the speed of the mass at the top of the incline. So there are various ways of solving this question. Method 1, let us use the basic work energy conversion. And what do I mean by that? Let's analyze the image in detail. So A is the initial point of the box. So A is the initial position of the box where the speed of the box was 0. The box is starting from rest and then it travels up the incline to reach a final position B. So one of the approaches to solve this question is using the work energy conversion. According to that, whenever any sort of a work is done, energy is transferred from one form to another. So in this case, if you analyze, this force of 6 Newton is pulling the box from A to B. So this force of 6 Newton is going to do some work, but that work is going to get translated into other energy forms. And what are those energy forms? The box is going to reach point B with some velocity. So at B, there is a gain in kinetic energy. And also, since the object has come above the ground, so potential energy has also increased. So now we can say that work done by this force of 6 newtons is going to increase the GPE and kinetic energy of the object. And the expression becomes the work done by the force will be equal to the change in potential energy plus the change in kinetic energy. Now the force, applied force is 6 newtons. So we need to figure out the work done by that force. So we use the basic formula F into S into cos theta. Magnitude of force is 6 newtons, displacement is 3 newtons, and the angle between the displacement and the force is 0 degrees. Because you can see in this image, A, B, and the force of 6 newtons are actually parallel to each other, which means the work done by the applied force comes out as 18 newtons. Now, for the change in potential energy as well as change in kinetic energy, we are going to use final minus initial. So, for delta PE, we'll write the final potential energy, final gravitational potential energy at B minus the gravitational potential energy at A. That will be delta PE. Similarly, the delta KE will be final kinetic energy minus the initial kinetic energy. Now, GPE at the point B will be mgh, where the height is 1 meters. Point A GPE can be considered as 0 because the height of A is 0. Kinetic energy at B is half mv square. Now that V is what we are supposed to find. And kinetic energy at A is 0 since the object was starting from rest, as it is mentioned in the question. So now if you put all these values in, work done was 18, GPE and kinetic energy expressions we have written down. And then if we try to simplify this, we are going to get 18 is equal to the mass of the box is 1, G is 10, and the height value is 1. So if we simplify all of this, we will get the value of V as 4, which means once the box crosses the point B, it is traveling with a speed of 4 meters per second. Now, coming back to the question, it is option B, which is the right answer.